Welcome to my presentation on a mathematical definition of property rights. I'll spend about the first 5 minutes just uh, introducing the academic field of, the field of theoretical economics and some core ideas in the field, and the remaining 20 minutes or so explaining some of my recent research in the area. I recommend that you open the paper that I've linked in the slide, because I've omitted some of the notational details and so on in the slides themselves. Philosophically, the field of theoretical economics, it's basically just game theory, or maybe a slight variant of game theory, can be considered a way of looking at what I like to call agent science, which is not standard terminology. And the way I would define it is that in theoretical economics, you consider utility functions to be an abstraction of agent behavior. That is to say, the agent, you're not necessarily thinking about what the right computational tools are in order to maximize utility. You're simply accepting that an agent maximizes utility, and go on to describe the interactions and welfare and so on from that point. This distinction that I make isn't perfectly precise, doesn't perfectly correspond with the practical definitions of the term, in the sense that there are fields like behavioral economics and ideas like bounded rationality within the framework of theoretical economics that talk about agents that do not perfectly maximize the utility functions and so on. But this is just for a basic introduction to the field. So perhaps one of the most important ideas in the field of theoretical economics is that of an abstract economy, which really gives credence to the idea that economics is the fundamental social science, or the correct way of doing social science. So it was introduced by Debrew and Arrow, and basically you have some number of agents with some choice sets X alpha for each agent, and they have a utility function that depends on the choices of all agents in the economy. And if you make certain assumptions about the choice sets and utility functions, you can prove that an equilibrium exists. And a particular result of importance, which was proved by Debrew and Arrow, is that an exchange economy, which is the standard model used in microeconomics, arises as a special case of an abstract economy. Basically, you have an abstract economy with a special agent called a market maker who sets prices, and other agents take the price and so on. But more importantly, other social science models can also arise as a special case of an abstract economy. This is the fundamental way of looking at social science as a game. So a particular field of theoretical economics, and this is more going towards this topic of my research, is known as property rights theory, which is which has to do with the concept of rights. And this concept has generally been discussed qualitatively. It was first introduced by Coase and was described rather qualitatively, in the sense that, clearly people have a great degree of intuition as to what rights mean, but a mathematical definition of rights in the context of an abstract economy, or even a Walrasian economy, hasn't been defined up to this stage. So property rights theorists have contributed various important insights into the field, like the existence of rights structures, and there is no economic consideration that distinguishes between two efficient right structures, as long as those right structures are non-attenuated, as they call it, which basically means that the right structure is enforced and it's not violated. But there are no formal definitions, no formal theorems, no formal framework in which theorems can be proved about equilibria in such an economy, and so on in the field. So here was my basic idea about how to define the concept of rights in an abstract economy. basically, to exercise a right means it's an additional choice. So, like, given your additional choice set, you take the product of that with some additional choices that determine what rights you choose to exercise. And for any action that another agent has, you may have the right to forbid that choice. So we want to say, ideally, that your choice set is some basic choice set, Cartesian multiplied by the product of the power sets of each other agent's choice sets. But this violates Cantor's theorem because it ends up with sets that are impossibly large. They contain their own power sets. So here, but nonetheless, I mean, we have an intuitive reason to want such a definition. So how can we formulate this mathematically? So we think about what kind of choices should be contained in the construction that we want, which would be represented by the pseudo definition that I put up here. We think about what such choices look like in English and formalize them mathematically. So, for example, I take an item from another person. Me take club from track. That's an example of a basic choice, a choice in X0. But that doesn't specify what kind of right I exercise. Like the full description of the action I make also includes details about what actions of track that I forbid. And of all other agents in the economy. So the second item in my in my list of examples includes some restriction on Thrax actions. But even in that description, Thrax actions are described as something of the X0 of Thrax choice set. And so you can extend this further, and you will get more and more precise specifications of my choice, like what precise action of track that I am forbidding, while clearly specifying what Thrax action itself is, in the sense of what actions is he forbidding, and so on and so forth. So, but because we're getting more and more precise, like the initial I mean, any finitely specified choice isn't truly precise because we haven't specified what choice in particular is being forbidden. So what we have intuitively is a way to project each choice into the previous one. That is how we have an intuitive understanding of each choice. This is very analogous to the mathematical concept of inverse limits. So here's how I chose to define the concept of rights. So instead of straightforwardly just defining the choice space itself, we define a sequence of xn, which are products of x0 with the power sets of the previous items in the in the choice space. Sorry, the previous items in the sequence, and we define the projections in the intuitive way that I described before. And you end up with an inverse family, and the inverse limit of this family is called the consentification of your initial choice space. I was a bit worried when I initially came up with this definition that I might have defined something vacuous, because even though it's defined in terms of an inverse limit, which is a well-defined concept, it seems intuitively that the construction would still violate Cantor. Would still violate Cantor's theorem. That because, I mean, intuitively we can imagine that we still have for any choice, we have some set of choices that it forbids. I mean, for any choice of me, there is a set of choices of track that I forbid, and for any set of choices of track, there is a particular choice. There is a minimal choice that I make, which only forbids those choices and makes some arbitrary action in the x0 space and does nothing else. So in that sense, you still have an injection from the power set to the set itself. So there must be something wrong with it. So I formalized it in a formal theorem prover called Reen. I formalized my definition in definitions in Reen, and it turned out, I mean, the definitions compiled properly. So I realized what the problem with that reasoning was, which is that it's actually not true that any set of Thrax choices has a choice in my choice set that forbids precisely those choices. So I've constructed an example here of a set of choices of Thrax, such that any choice I make which forbids those choices also forbids a choice that is not contained in that choice set, in that subset of the choice set. So basically, you have a bunch of choices, and those choices are successively closer and closer to a particular choice, which isn't contained in that set of choices itself, but it's provable. But that limiting choice must also be forbidden by any choice of mine that forbids that set of choices. I'm sorry if that's confusing. If that's confusing, you just need to read the math itself. So that's, I mean, intuitively, that is the idea behind limits, right? That's the idea behind topology. So we can define a topology on our consentified choice space, defined as in the slide, in the sense that, and the closed sets of this topology, you can prove that this actually forms a topology. The closed sets are precisely those sets which may be forbidden by a choice. That is to say, a closed set of Thrax choices is the only any set of choices that I choose to forbid of Thrax is necessarily a closed subset of Thrax choice set. So remember when I said that what we want to say is that the choice set of agent alpha is the product of some basic choice set with the product of the power sets of all of the choice sets of all other agents. But instead of the power sets, if we replace that with the topologies of the other agents, where the topology is defined in terms of closed sets, then that statement would be true. And so instead of the standard construction by Arrow and DeBrew of an exchange economy as arising from an abstract economy with a market maker, we're able to define an exchange economy as coming from an abstract economy with some right structure without the presence of any additional market maker, which is perhaps more intuitive in the sense that it more naturally describes how agents interact in a real economy. So, I mean, here I've specified how an abstract economy corresponding to a particular exchange economy looks like. I haven't really described the notation in the slide itself. That's specified in the paper, exactly what conditions are required on each choice set, and so on and so forth. So, however, I haven't, I mean, while I've explained the mathematical theory behind right structures itself to some detail, I haven't done much work yet towards actually proving the existence of equilibrium, because the standard theorem for the existence of equilibrium for an abstract economy no longer applies to an abstract economy with the right structure, because you no longer have a compact set and so on and so forth. I mean, your resulting set isn't a choice set isn't even a subset of Rn. So figuring out in what circumstance an equilibrium exists, in what circumstance an equilibrium corresponds to a price. If you noticed here, the last definition on this slide is the definition of a price in an abstract economy with rights. Because basically a price is you saying that I forbid you from taking some of my things unless you choose to not forbid me from taking some of your things. So the description of price and non-price equilibria of a consentified economy, and whether non-price equilibria are somehow less inefficient or somehow less preferable to a price equilibrium, whether differential pricing can occur or ought to occur in in a consentified economy without a market maker. Those are areas for future research, as well as having the theory of transferable rights. So
I think we have some technical issues. I don't know if this is me.
transfer of rights. Sorry.
I think you froze for a second.
Oh, can you hear me now?
Yeah, no, we can hear you. I think we missed about 20 seconds, perhaps.
Oh, okay. Yeah. So I mean, I was just describing some future work that remains to be done regarding the price theory, the existence of price and non-price equilibria in a consentified economy, whether non-price equilibria are efficient or not, and so on. Yeah. So second, we need to look at at production economies, because so far the only construction that I've made is for pure exchange economies without a notion of transformation of goods. And this is closely related to the concept of transferable rights, because number one, a transfer of rights entails a transformation of that right in the formulation that I've expressed it so far. Because, for example, if I sell you a right to till some land, for example, what that right entails to me is that I have the right to forbid someone else from forbid me from tilling that land. What it entails to you is that you have the right to forbid someone else from forbidding you to till that land. So those are mathematically two different rights. So that involves the transformation of rights. And secondly, production requires rights as a cost of production. So I mean, I expect these ideas to be rather related, and I'm not yet sure whether it requires a further modification to our definition of rights itself. A third area I'm quite interested in is looking at the implications of property rights theory on welfare economics. So I mean, analogously to how we can have different right structures, and there's no way to discriminate between these right structures as long as they are non-attenuated. Similarly, we can have multiple measures of welfare defined in welfare economics. So, because you can't just aggregate utility functions, right? You can't add two utility functions. That doesn't make any sense. So there are definitions of welfare of welfare aggregations that depend on some notion of value, like compensating value. And the way you aggregate them, there's no fundamental way to determine that. So a question I'm interested in is are there any provable results, like this particular right structure maximizes this particular metric of welfare, and a way to determine a metric of welfare that is maximized by a given right structure and vice versa? Thank you.